The world that never sleeps. The modern digital world does not wait. Every second, someone places an order. A payment is confirmed. A notification is sent. A shipment is scheduled. A recommendation is updated. A system reacts. And yet, most people imagine software as something that waits to be asked. A request comes in, the system responds. End of story. But that mental model quietly breaks down the moment scale, speed, and complexity enter the room. Tonight, we're telling the story of how software learned to react instead of wait. How systems stopped calling each other endlessly and started listening. This is the story of event-driven architecture. The city of requests. Imagine a city, a massive digital city. Every building represents a service. Payments live in one building, orders in another, inventory in another, notifications, shipping, fraud detection, each in their own towers. At first, this city runs on direct conversations. Whenever something happens, a service walks across the street and knocks on another service's door. Hey, an order was created. Please reserve inventory. Hey, inventory reserved. Please charge the customer. Hey, payment successful. Please schedule delivery. It works for a while, until traffic grows, until buildings multiply, until every knock depends on another knock. And then one day, one service doesn't answer. Suddenly, the whole street freezes. Welcome to the tightly coupled city. The night everything slowed down. A real story. An e-commerce platform running a flash sale. Thousands of users, orders pouring in. The order service calls the payment service. The payment service calls fraud detection. Fraud detection calls user verification. Inventory waits. Shipping waits. Notifications pile up. Then, fraud detection slows down. Not fails, just slows. Orders back up. Threads block. Timeouts cascade. Customers refresh pages, payments hang, support tickets explode. Nothing is technically down, but everything feels broken. This is the hidden cost of synchronous thinking. The question that changed everything. An engineer asks a simple question. What if services didn't have to wait for each other? What if, instead of calling each other directly, they just announced what happened? No demands, no waiting, no tight dependencies, just facts. An event. What is an event? An event is not a command. It doesn't say, do this. It says, this happened. Order created, payment completed, user registered, item shipped. An event is history. It is immutable. It already happened. You cannot argue with it. You can only react. The city learns to listen. Back to our city, instead of knocking on doors, services post messages to a public board in the city square. Order created. That's it. No addresses, no instructions, no waiting. Every service that cares listens. Inventory sees it and reserves stock. Payments see it and charges the card. Notifications see it and sends an email. Analytics see it and updates dashboards. Fraud detection listens quietly in the background. No service knows who is listening. No service cares. This is decoupling. This is event-driven architecture. The power of not knowing. Here's the uncomfortable truth. In event-driven systems, ignorance is a feature. The order service does not know who processes payments, who sends emails, who logs analytics, who flags fraud. And that ignorance makes the system stronger. You can add a new service tomorrow. No redeploys, no code changes. Just subscribe to the event. The city grows without traffic jams. Real world. Uber. When you request a ride on Uber, an event is fired. Ride requested. That single event triggers driver matching, pricing calculations, ETA predictions, notifications, maps updates. None of these services call each other directly.
they react. This is how Uber scales to millions of rides without collapsing under its own weight. Event streams, not messages. At scale, events don't just pass through, they flow. Through Kafka, through Pulsar, through cloud event buses. Events are stored, replayed, consumed at different speeds. A new analytics service can rewind history and rebuild insights. Time becomes queryable. Your system remembers everything that happened. The dark side. Event-driven architecture is powerful, but it is not magic. Debugging becomes harder. Flows become invisible. Failures don't scream, they whisper. An event can be published successfully and still never processed. Observability becomes non-negotiable. Tracing becomes essential. Logs become lifelines. EDA rewards discipline. It punishes chaos. Eventual consistency. In event-driven systems, things don't update instantly everywhere, and that's okay. Your order may show processing for a moment. Inventory updates slightly later. Shipping follows after. This is eventual consistency. Not broken, not wrong, just asynchronous reality. Banks use it, airlines use it, stock exchanges use it. Speed comes from letting go of immediacy. When to use it and when not to. Event-driven architecture shines when systems must scale independently. Features change often. Teams work autonomously. Real-time reactions matter. It struggles when workflows are simple. Strong consistency is required everywhere. Teams lack observability maturity. EDA is a power tool, not a starter kit. The quiet revolution. Most users never see it. They just feel faster systems, fewer outages, smoother experiences. Behind the scenes, events flow, services listen, systems breathe. The software world stopped shouting instructions and started listening to reality. The lesson. The biggest shift in modern architecture wasn't microservices, it was how they talked. From commands to conversations, from requests to reactions, from waiting to listening. That is event-driven architecture. Not a pattern, not a tool, a philosophy. If you understand events, you understand how modern systems think. And once you see the world as events, you never design software the same way again. Thank you for watching, and if this story resonates with you, kindly share your thoughts.